All right, so as we're going into the discussion of the check your understanding problems for the homework for this, I did want to kind of talk about, I added an additional property in there. As I finished it up, I realized that there was one that I had not added in, so I decided to add that in for you. And this is this number 6 down here. Now, I did it in one of the previous problems, so if we slide down and take a look at the example that we did, specifically, I'm looking at this portion of the problem. That when we were looking at the definite integral from 0 to 16 of 5 dt, we were looking at this area, which was a rectangle area that's there. And when we were looking at it, the constant itself that was right here, this constant represents the height of the rectangle. And so the 16, of course, is representing the width of the rectangle. And the idea is that how I was calculating the width of the rectangle is I was simply doing 16 and 0 and calculating the distance between that. So if we take a look here in the table, what I added for number 6 there is that the definite integral from a to b of a constant is really always just looking at the rectangle area under a horizontal line from a to b. So the width that we're going to be talking about of our rectangle, b minus a, is going to be your width of the rectangle. K is going to be your height that's there, and in the area of the rectangle is simply the width times the height. So k times b minus a is going to be how we would calculate that. So I did want to add that in because that was something that you did need to use in your homework. So sorry, hopefully you kind of caught that and did that yourself. So coming down here to check our understanding, you do want to kind of get into the habit of when you are doing these problems, because you have to show your work if I was on an FRQ, to make sure you're showing what you did. So to get the integral from 9 to 7 over here, I know that that's in the reverse order from what I was given in the problem. I was given from 7 to 9 right here. And you don't want to go straight to an answer. You do want to show them what you did. So notice that I showed that it was the opposite of the integral from 7 to 9 of f of x dx. And so that's the quote unquote the work that you were going to show how you got it. And then of course giving your answer. The second problem that we looked at over here, I had to go from -3 to 7, but I did not have a -3 to 7 or a 7 to -3. I only had -3 to 9. Now make sure that your ending and your beginning match for those, and then you would simply add them together. Notice I'm using part A to do part B here. So I got 13 for my answer for that one. I'll just highlight the answers. So we have that 5 and 13. All right, down here for part C, taking a look at that, that was pretty straightforward. Combine two properties together. The definite integral of a sum is the sum of the definite integrals, and I also pulled the constant out because the constants are righter, so it pulls to the front. So I show my work for getting the 30. The last one, the definite integral of a difference is the difference of the definite integrals. So that got me down to this portion right here. And then that's where I used that property I showed you in number 6 that I added in, that the definite integral from -3 to 9 of 2, which is just a constant, would be 2 times b minus a, 9 minus -3 for that. All right, same thing here, kind of going into the little area under the curve with the um, little geometric shapes. So the first thing I did is I went through and I calculated each of the areas for the little shapes between that and the x-axis. And I did, as I was calculating them, of course, the ones that are below are negative. So these were all negative, and I broke it up mostly because I was looking over here and I saw things like -2 to 0. And so that would kind of make it easy to break it there. And I did the same thing here. And then, of course, the positive areas above here and here. So it was just one of those things that I felt was better to do like subsections as I go across. So the interval from -2 to 0, here's -2 and here's 0. So I was moving forward through the definite integral through the area. So I did use the negative pi. For the -2 to 6 for B, the negative that's on the inside right here, notice I pulled it out to the front. And then when I pull it out to the front, then I was doing a forward interval from -2 all the way to 6. So then I was adding up the areas until 6 is all the way over here. So that was that section, and I was adding them up. But then I had to remember that you have to do the opposite. So there were two negative pi's that I added, and then the 16 that I added, and then we multiply by the -1 to switch it. And so that gave us our final answers for that. So negative pi and the 2 pi minus 16. Now, the next one I did want to talk about in a little bit more detail because this is something that's going to be important kind of as we start doing application problems. If I was doing the definite integral from 0 to 6 of just h of x, that would be net area. So positive versus negative areas above and below. So you would add and you would subtract. But when you put that absolute value in there, and this is kind of going back to our particle motion problems, there's a difference between displacement and total distance traveled. So the net area is your displacement, while the total area is going to be your total distance traveled. So the total area, when they put that absolute value in, that just means you're going to add up all the quote unquote area, and area is always positive in that context. So that's why it ends up being positive pi instead of negative pi in that. All right, and then my last problem here, I was going from -2 to -4, and then you have to watch for this as you're working your FRQs, that -2 to -4 is going reverse direction, so it's heading in that way. So when I go in reverse direction, I have to remember it's the opposite of what it was going in the forward direction. So we originally had a -4 down underneath of there, so I had taken out 4, so if I go backwards, I'm going to add the 4 back in, and that's why that is a +4. All right, so hopefully that did okay on that properties. Again, the idea is that if you are in an FRQ, that you do want to kind of make sure that you are showing what you did as you were calculating it. All right, so that'll end class note 6.6. So the next thing we're going to do is we're going to go into the class notes for 6.7, which is going to go back to the second part of the fundamental theorem of calculus and really make that direct connection between definite integrals and antiderivatives and the fundamental theorem of calculus. So that will be our next video. And then that will finish out the new material for this week, and then you'll have all of those practice worksheets to do.